Okay, so for my semester project, I worked with a programming language called Ruby. My project was to document the language and to get a handle on some basic programming in Ruby. So what I'm going to do for you today is present a very brief walkthrough of some of the structures in Ruby and point out some interesting features. So Ruby is object-oriented and interpreted, and everything about it is designed with simplicity in mind. This means that readability, intuition, and simplicity were very important in the design of this language. What that means is the syntax of the language was designed to be clear and to flow almost as if just reading any other natural language when reading this code. The idea being that editors and readers should be able to look at this code and be able to derive the meaning from the actual words that are being used in their arrangement rather than what they know that the syntax is defined to represent. So in this example, this is a function that we wrote in Scheme for like assignment 2 or something like that. Now if we look at this, we know kind of what it's doing just because we've been working with Scheme all semester and we're very experienced with it. And we're able to probably parse through this ourselves and very quickly derive the meaning. But for someone who's not experienced with Scheme or even has never seen Scheme before, the meaning of this code is obscured by the presence of the parentheses, the strange ordering of having the operator come first and then the operands afterwards, and it's often not clear what's doing what if you're just looking at this code. I don't think someone who's never seen Scheme before could just read through this and decipher what it means. On the other hand, we have Ruby over here. This is the same function that I defined in Ruby, and you can almost read through it and derive the meaning just by reading. Defining a function called member takes s in an array. If the array is empty, return false unless s is empty, in which case you return true. Otherwise, if s is the first element in the array, return true. Otherwise, if the length of the array is 1, and so on. And you can see that it reads very logically and very clearly and in a way that's interpretable simply from just reading the words. Not every function ends up reading as nicely as this, but I thought this is a good example, good comparison of like what we're talking about when we mean it's readable. So everything in Ruby is an object. That's why it's object-oriented. An object means it's just a thing that can be modified or stored or passed to functions or given attributes or just used as a thing that's passable between different other things in Ruby. Each object is an instance of a particular class, and the class that this object belongs to defines its intrinsic properties and maybe gives it an initial set of properties, and also means that there are a specific set of methods that can operate on this object. So everything in Ruby, since every object has a class, the overriding class, the one that everything in Ruby belongs to, is the class object. Directly below that are kind of the distribution of different instance types in Ruby. So for example, array, string, hash, numeric. These are all direct subclasses of object, and everything in Ruby is just kind of sorted into these classes. So for example, every number is a member of class numeric. Numeric is split into integer and float, and so a number will get sorted into either integer or float. Integer is sorted into fixed number, big num, and kind of along the way, as an object is belonging to certain sets, it inherits the properties that go along with being part of that set. Interestingly, class is a subclass of a class called module. So class is actually defined within this class structure, and class is an object. So I guess this kind of reinforces the way we think about Ruby, where each object is part of a class, but class is really an object. So what's really being stressed here is that this object structure of Ruby is what's important, and not the fact that it's in classes. The classes are a subset of the fact that everything is an object with certain properties. So here's an example I wrote up of a class being defined. It's a class that takes a candidate for a certain job and a list of credentials. Actually, this job is a programming job specifically. A list of credentials. This asterisk here means it can take any number of parameters, and it just calls them a list called, or an array called credentials. So this first function is kind of initializing the person's credentials, and then the second function is determining if this person is an experienced enough programmer to work for whatever programming company we designed. And we see that like the credentials list is split into years of experience, points on GitHub, age, whether or not they've applied recently, and languages that they've worked with before. And this statement right here is just saying we're going to return that this person is an experienced programmer if they have at least 2 years of experience or at least 500 points on GitHub. If they're at least 15 years old, if they've applied recently, if they haven't applied recently, and if they've worked with Ruby before. So I submitted my own resume to this, and we can kind of see how this object structure works if we go through this code. So I take John and assign it a new candidate object, and we see that this is the representation of that object. I submit my resume, which is I say that I've had 3 years of programming experience. I've never used GitHub, so I don't have any points there. 21 years old, I've never applied before, and I know Python, Scheme, and Ruby. And if I then go back and check John again, the object now has an attribute credential. So we see that as we go along defining aspects of this object, they get tacked on to the actual object definition. And then finally, is John an experienced programmer? Of course he is. I said earlier that classes are types of modules, but never really said what a module is. In Ruby, a module is just a collection of methods and constants that describe the behavior of a particular object. So if we want, while we're creating a class, if we don't want to define a bunch of methods, if we think they're defined somewhere else, we can just include the module that has defined those already. So for example, here I create a module called stretch, where we define a bunch of functions for stretching different body parts before a workout. Stretch your calves, stretch your hamstrings, stretch your shoulders. Apparently that's all you need to be fully prepared for a workout. And define warm-up just kind of does all these things and then returns true. But see, this is just defining the behavior of an object. It's not really doing anything with it. If we then move on to, for example, I could create a class called dancer. We create an object that's a dancer, including the class stretch, and then we can say whether or not this dancer has warmed up yet. So here, if we call the function get warmed up, then it calls warm up, and warm up is actually the function from stretch, not from dancer. But because we've included stretch, any dancer object also has available to it the functions that we defined in stretch. And then I said this dancer knows how to tango, so if you ask it to tango, it'll either do the tango or try to tango and get injured, depending on whether or not it's warmed up. So here's the example. I made John a dancer, he's an object. Try to tango, and he gets injured because he hasn't warmed up yet. Ask him to warm up, goes through the whole warm-up process, he's ready to go. We check John's object again, and now we can see that he's got an attribute now that says that he's warmed up, and you ask him to tango, and he's fine. But the important part of modules is that we can save time, because if we define another class called runner, we don't need to define a new module or a new set of functions for stretching, because stretching in this fictional world of working out, stretching for running is the same as stretching for dancing. So we can define just a very similar structure, make John a runner, ask him to sprint, but he gets hurt. Ask him to warm up the same way we did in the dancing expression, and we get this use of the module again here. And afterwards, he's fine to sprint. So I've been using the word method a lot. Method is really just a way of expressing functions in Ruby, but all functions in Ruby are assigned a particular set of classes that they can operate on. So for example, if I define this array 1, 2, 3 and ask the array to pop, I get the top element of that array, which is the number 3. But if I convert the array to a string using this 2s method here, then I get the string 1, 2, because the 3 isn't popped off. So we get a string 1, 2. If I then try to pop the array, it doesn't work because pop is not a method that's defined on strings. It's only defined on arrays. Variables and constants. So local variables are handled the same way that we've seen them handled in Scheme. We jump ahead here. Ruby's mostly lexically scoped, so local variables are only visible within whatever chunk of code that you define them in, whether it's a definition or a block, which we'll talk about later. But when you define a variable, anything that you define, any assignment that you make using a name that has a lowercase letter as the first letter becomes a variable. The rest of it's not case sensitive. But the first letter of that string is important, because if you use a capitalized letter instead of a lowercase letter as that first letter in the string in the assignment, Ruby recognizes that as a constant instead of a variable. Now they both behave the same way as a local variable in the sense that we've seen. We can assign it a value and then call it later if we want. But it's a reassignment that Ruby handles differently. So here we've got just a standard local variable being defined and then called, reassigned and then called. But here, if we make it a constant instead of a variable and try and do the same thing, Ruby will complain that we've reassigned pi because we said that pi was a constant, not a variable. So Ruby does a lot of things like this where it prevents confusion by, it still allows you to do this reassignment, but it will tell you that, by the way, you said this was a constant, so you probably shouldn't be doing this. Kind of in that same vein, global variables, instant variables, class variables, the different types of variables that you're using are all notated differently, so that you've actually got something besides the scope in which the variable's been defined to indicate what kind of variable it is. So a symbol is kind of a unique object to Ruby, at least unique in the sense that I've never seen it anywhere other than Ruby. Symbol is defined in Ruby as an object that has both a string representation and an integer representation. But I've only really seen the string representation used. I don't really know how the integer one is used. But the point is that symbols are used to save us memory. So for example, say we want to indicate that Damon and Becky are both my friend. I can assign them both, I can make them both variables and then assign them the value string my friend, and then when you call Damon or call Becky, it'll return the string my friend. However, if we look, even though they've been assigned to the same string, if we look at Damon and Becky's object IDs, we see that Damon and Becky are two distinct objects. The object that they've been assigned to has different identification tags. So we've defined two pointers to two different objects by doing this. Whereas if we go over the symbol, we define as my friend as a symbol using the little colon in front of the name of the symbol. If we assign Damon and Becky to the same symbol, they end up being assigned to the same object. So now we have two pointers pointing to one object instead of two. So here we have Ruby's version of a closure. They call it a block. But a block is basically just any set of instructions that have been grouped together using either a do end or a set of curly braces. So in this example, we're changing an array to multiply each element of the array by 3. We can do that by mapping onto a block here where we define a block parameter and have that parameter multiplied by 3 in each case of in each element of the array that's passed to it. So here we see again that idea of lexical scope in Ruby, that this I is inaccessible outside of this block of code.